This is the 8.5 mini lesson. To explore one of the last unknown regions on our planet, companies are starting to produce single-person submersible deep-sea submarines like the Deep Flight One. This submersible can dive to a depth of 3,300 feet below sea level at a rate of 480 feet per minute. We're going to need these two numbers as we work through the lesson. Suppose Deep Flight One is going to do a dive starting at sea level. Identify the independent and dependent quantities. So I'm going to start there. Independent is the time in minutes. The dependent is going to be the depth in feet, because the depth depends on how long the submarine has been traveling. Also, their unit of measure, that's why I have minutes and feet. And I have to define variables, T and D, and I need to write an equation. So if we think about this, the depth of the submarine is going to be negative 480 feet every single minute. So there's my equation. So I'm going to now put all of this into a table. Remember, here's X, here's Y. My independent variable is always my X, my dependent's my Y. So time is my independent, it's in minutes, it's T. Depth is in feet, it's a D. So when we start off, so here's my beautiful picture. I start off at 0 seconds, but every minute that I go down, I'm going 480 feet below sea level. So technically, I'm really going negative 480 feet. So at 0 time, I'm sitting at the top of the water, 0. 1 minute, I'm at negative 480 feet. So 2 minutes, and I'm just keep plugging in here. Negative 480 times 2 is negative 960. And so you can fill this table in. Now I took the table out one additional piece, and we'll talk about that in a minute. So at 6, it's negative 2,880. And at 7, it's negative 3,360. So why does the table end at 6 minutes for this problem situation? So the submarine, remember, could only dive to a depth of 3,300 feet. If we went 7 minutes, it would be beyond that depth. The submarine is not capable of handling that kind of depth. So the submarine can only dive to negative 3,300 feet. And at 7 minutes, it would be at negative 3,360 feet, which it's not capable of doing. So examine your table. What do you notice about each depth value in relation to the one before and the one after? So when I look here, the one before is 480 feet more. So it's like taking this plus 480 feet. This is like taking this and subtracting 480 feet. So the value before is 480 feet more. The value below is 480 feet less. So in this problem, what is the unit rate of change? We go in a negative direction 480 feet every minute. Unit rate of change is the amount that the dependent value changes for every one of the independent. So for every 1 minute, how much does it drop in feet? 480. So how deep would the submarine be after 2.5 minutes? So if I use my equation, D equals negative 480 times 2.5. So when I multiply that together, the depth would be negative 1,200 feet after 2.5 minutes. Now, 90 seconds, we have to really pay attention to labels. 90 seconds, we're talking minutes. So that's 1.5 minutes. So now D equals negative 480T. D equals negative 480 times 1.5. If we multiply those, we get the depth would be negative 720 feet. Notice I'm always using labels. and 45 seconds, I could use 3/4 of a minute, or I could use 0.75. I'm going to try a fraction this time. D equals negative 480 t. D equals negative 480 over 1 times 3/4. Negative times a positive is a negative. 4 goes in 4 once. 4 goes in here 120. 120 times 3, so negative 360 feet. How many minutes would it take deep flight to be 1,400 feet below sea level? Make sure we're reading carefully. Below sea level means that is a negative 1,400, and that's now the depth. So I have to algebraically solve this. Divide by negative 480, divide by negative 480. So when we divide those, I get approximately 2.92 minutes. So if I'm going to do 2,100 feet below sea level, remember that's a negative number then. Again, I'm dividing both sides by negative 480. So if I take 2,100 divided by 480, a negative divided by a negative is a positive. I get 4.375 minutes. So in 4.375 minutes, I would be 2,100 feet below sea level. Now what about at its maximum depth? Maximum depth was negative 3,300. So again, if we substitute and solve our equation, I divide by negative 480, divide by negative 480, negative divided by a negative is positive. I get 6.875 minutes. So remember how we had said we could not go to 7 minutes? If we go back to the table, it would be at 6.87 minutes is when it would be at its maximum depth of 3,300 feet. So now we're going to construct a graph. We're supposed to label the x-axis and the y-axis. So my x, I have to kind of look at where this is, because when you look at a graph, they're really using this quadrant right down here. Here's my time, and my feet, I'm going below sea level. So it's this part of the graph that they're showing me. So time in minutes, depth in feet. I plotted all my points. Now remember, once you plot points, you should ask yourself, should I be connecting these points? And I decide that by saying, could I have parts of minutes? Which sure, the submarine could be traveling for a minute and a half, and it could be traveling for part of a foot. So in this problem, it would make sense for me to connect my points. And that would be called continuous data. So now we're going to use the graph to decide what time deep flight will be above 1,400 feet below sea level. So it looks like it took 3 minutes to get here, but we want to know when is it going to be above that. So it looks like any time before 3 minutes. So this picture really helps me. Now I want to decide what the time will be when it's below 2,100. So I'm looking like when that submarine is going to be down here. And it looks like it's here at about 4.5 minutes. So it would mean any time after about 4.5 minutes. So I can't get an exact by looking